When it comes to preparing metal edges for welding, the quality of the edge can make all the difference between a strong, durable weld and one that is prone to failure. That's why welders often turn to carbide burrs, specialized rotary cutting tools engineered for precision and efficiency. Carbide burrs are renowned for their ability to bevel and chamfer metal edges, ensuring optimal weld penetration and fusion. Let's explore how these tools are used, why they're so effective, and the best practices for incorporating them into the welding preparation process. Carbide burrs are small, rotary tools designed with intricate fluted patterns and manufactured from ultra-durable tungsten carbide. This material is exceptionally hard, significantly harder than the metals most welders encounter, which allows carbide burrs to slice through steel, stainless steel, aluminum, and even tougher alloys like titanium without losing their edge. Mounted on high-speed die grinders, these burrs spin at impressive rates, typically between 10,000 and 25,000 revolutions per minute, enabling them to rapidly and accurately remove material from metal surfaces. One of the primary uses of carbide burrs in welding is for beveling. Beveling is the process of cutting an angled edge, often between 30 and 45 degrees, on a workpiece. This step is essential for creating V, J, or U-shaped grooves, which play a critical role in weld joint design. By forming these grooves, welders provide a channel for the weld bead to penetrate deeply into the base metals, resulting in a joint that is both strong and resistant to defects like incomplete fusion or lack of penetration. To begin the beveling process, a welder selects a carbide burr suited for the desired groove shape. For example, a cone-shaped or tapered burr is ideal for forming precise angles along the edge of the metal. The burr is securely attached to the die grinder, and the welder ensures the tool is operating at the appropriate speed for the material and burr size in use. With a steady hand, the welder guides the burr along the edge of the workpiece, carefully removing material to form a uniform, angled bevel. This level of control is particularly valuable when working on small or complex parts where larger, more aggressive tools like angle grinders could remove too much material or lack the precision required for intricate work. Throughout the beveling process, the welder pays close attention to the angle and depth of the cut. Consistency is key. A uniform bevel ensures that the groove matches the intended joint design and will allow for even weld penetration. After the initial cut, the edge is typically cleaned with a wire brush or sanding disc to remove any remaining metal shavings or debris. This leaves a smooth, clean surface, ready for welding. Chamfering is another common task for which carbide burrs excel. While similar to beveling, chamfering involves creating a smaller angled edge, often at 45 degrees, primarily to remove sharp corners or to prepare edges for specific joint types, such as fillet welds. Chamfering not only improves safety by eliminating potentially hazardous sharp edges, but also enhances weld accessibility, particularly in tight or awkward spaces. For chamfering, welders might select a ball-shaped, cylindrical, or tapered burr, depending on the desired edge profile. As with beveling, the burr is mounted on a die grinder set to the appropriate speed. The welder applies light, controlled pressure, guiding the burr along the edge to create a clean, angled cut. Chamfering generally requires less material removal than beveling, so the focus is on precision rather than speed. Multiple light passes help prevent overcutting, ensuring the chamfer is both uniform and subtle. After chamfering, the edge is carefully inspected and cleaned to ensure it meets the specifications required for the intended weld. A properly chamfered edge can make a significant difference in the ease and quality of the subsequent welding process. So, why are carbide burrs the tool of choice for these critical preparation steps? There are several compelling reasons. First, their precision is unmatched. Carbide burrs can handle detailed work on small, intricate, or hard-to-reach areas where bulkier tools simply cannot operate effectively. This makes them invaluable in industries where precision is paramount, such as aerospace, automotive, and custom fabrication. Second, carbide burrs are incredibly versatile. They work effectively on a wide range of metals, from mild steel and stainless steel to softer materials like aluminum and even exotic alloys. By selecting different burr shapes and adjusting techniques, welders can create a variety of edge profiles, from sharp bevels to gentle chamfers. Durability is another significant advantage. Tungsten carbide's extreme hardness means that these burrs maintain their sharpness and cutting ability through prolonged use, even on challenging materials. This translates to longer tool life and reduced downtime for tool changes, leading to greater efficiency in the workshop. Efficiency is further enhanced by the high-speed operation and sharp flutes of carbide burrs. They can remove material quickly, saving valuable time without sacrificing control or precision. This is especially important when preparing multiple pieces for production welding, where consistency and speed are both essential. To make the most of carbide burrs, welders adhere to several best practices. Safety is always the first priority. Wearing personal protective equipment such as gloves, safety glasses, and dust masks helps protect against flying metal chips and harmful dust. Matching the die grinder's speed to the size and type of burr, as well as the material being worked, ensures optimal cutting performance and minimizes the risk of overheating. Selecting the right burr for the job is crucial. Double-cut burrs are ideal for general-purpose beveling and chamfering on harder metals, providing smooth control and efficient material removal. For softer metals like aluminum, single-cut burrs are preferred to prevent clogging and ensure a clean cut. Finally, welders monitor their work closely throughout the process. Periodically pausing to allow the workpiece to cool prevents heat buildup, which could negatively affect the metal's properties and ultimately the quality of the weld. After beveling or chamfering, a thorough inspection ensures the edge preparation matches the joint design and meets the requirements of the specific welding process being used, whether it's MIG, TIG, or another technique. In summary, carbide burrs offer welders a powerful combination of precision, versatility, durability, and efficiency for beveling and chamfering metal edges. Their proper use is a critical step in achieving clean, strong, and defect-free welds, an essential foundation for any high-quality fabrication project.